we have gs equal to 20s over s plus 10. So as we can see here, we have 1 0, which is s equal to 0, and we have one bool at s equal to -10. So the first, you need to highlight how many zeros do you have and how many bools do you have here. So we have one bool and 1 0. So this is the bool here, I mean the 0, which is s in the numerator. And if this s equal to 0, so the whole function or whole transfer function will be equal to 0. And we have one bool, which make the denominator equal to 0, which is -10. So s equal to 0, this is our 0, z1. And we have one bool, which is p1, s equal to -10. So we have one bool and 1 0. So how we can convert this transfer function into this standard form, to its standard form? We need to divide by 10 here. In order to make this one, we need to divide by 10. So the new function here will be like, if I divide this is by 10, so 10 over 10 it will be 1, s over 10 it will be 0.1 s, or s over 10 it is the same, and 20 over 10 it will be 2. So the new standard form here for our transfer function will be 2s over 0.1s plus 1, or over s over 10 plus 1, whatever is the value. So our 0 here is at the point of 10. Okay. The second step here, we need to identify the various factors or various components of this transfer function based on our distribution. Last time we said we have five types of component, which is the magnitude, which is the integral, derivative, and also the first order 0 and the first order bools. So based on this criteria here, we need to identify what are the components for our transfer function. What is the gain? What is the integral or derivative factors? What is the first order 0 or the first order bools? So we refer back to the example here. So we have one gain, which the gain k here is equal to 2, and we have one integral or 1 0 at the origin. Okay, so which is s. So actually this is the derivative, and we have two or one bool at the our first order bool, which is the 0.1 s over 1 for this element. Okay, so we can highlight these three elements because these three elements or three components need to be drawn or sketched individually. Then we are going to combine. So previously we said if we have a gain, so the magnitude of the gain will equal to the 20 log the gain value. So for example here we have the gain is equal to 2. So our magnitude, the magnitude of this gain here of the k value will equal to 20 log 2. So that means if I want to draw this line, I mean this magnitude in the semi-log paper, I'm going to draw a line with its at the point 20 log 2 in dB. So what is 20 log 2? Just use your calculator to find what is the value of log 2, then multiply by 20. So what if you have, in the case of your assignment, for example, you already given the value. If I give you, for example, in the previous example here, we have 20, for the 5K, I think, in the previous example for K. If you remember here, we have K equal to 5, correct? We have K equal to 5, and we said when we want to draw, we have 20 log 5, which is 14 dB. What if I gave you only this, the 14 dB? Can you find what is the value of K? If I give you the line here, I said this line is 14 dB. How you can tell me that the magnitude is equal to 5? Who will answer this question? I mean, if I give you I just give you drawing here for semi-log, and I draw line 14 here, which is equal to 14 dB. Don't, in message, I cannot see. Okay, just let me know now. Who will answer this one? How we can convert this 14 dB into its original value 5K? K equal to 5. Anyone? Chong,
Yes, sir.
how we can show that the 14 is equal to 5? How we can convert the 14 to 5? What should we do?
Use the 10 power of the
Yes, that means
value.
you just use your calculator. There is log inverse, which is the 10 to the power, correct? I mean, just make inverse log for the 14. It will and divide it over 20 because this number here is 20 log k, correct? That means if you want to find the k, so k will be equal to 1 over 20 log inverse k. So just try to convert the 14 to get the 5 value, so you can confirm that your answer is correct or not. How you confirm this one? If we say 20 log k is equal to 14, so that means log k equal to 14 over 20. So k will equal to log inverse 14 over 20. So in this case, you can find the value of 5, or you prove that the 5 is the magnitude of your transfer function. So just refer to the example here. I mean, in our example here, k equal to 2. So if I want to draw, so it will be like 20 log 2. What is log 2 here? What's the value for log 2? You can see here. So gain factor 2 here, 20 log 2, which equal to 6 dB. That means our semi-log paper will include one line, we add 6 dB. One straight line add 6 dB. Okay. Then we go to the second element, which is the derivative factor S. So the derivative factor S, which is represent the 0 point at the origin, we have the magnitude of this point. We said it's equal to 20 log omega. And we already see that if we have derivative from these graphs, I told you this is the common, or the standard graph. If you have a derivative value, here, if you have the derivative value, which is j omega here, so it will be like the drawing will be 20 dB per decade. So this is the standard. Whatever you calculate it, you take it from the table, you memorize, whatever, it is 20 dB per decade. Okay, so this drawing for this one will be 20 dB per decade. That means it will change from if you start from point 1 until 1, it will change by 20 dB per decade. It will increase by 20 dB. From 1 until 10, it will increase by 20 dB. From 10 until 100, it will increase by another 20 dB, and so on. Okay, slow. Then the third one, which is the first order, pool. This will be, as we said before, it will be like high pass filter. It will start from omega 1, which is the value of the 0, or the value, the value of the bull. Then from this value of the bull, it will go for negative 20 dB per decade. It's like this one. At the point number, at the point of omega, which is here s over 10, correct? So at the point of 10 here, it will convert to negative 20 dB per decade. As you can see here, so we have 6 dB, we have 20 dB, and we have negative 20 dB per decade. Will start at the omega is equal to 10. If we draw these three lines, it will be like this one. This is the 6 dB the 6 dB value for the gain. The black line here. This is the line for the 6 dB, which is come from the gain of equal to 2. And the second line here start from negative 20 up to, for example, here from point 1. This is one decade. This is another decade. This is another decade. This is another decade. So for the first decade here, it will increase from negative 20 until 0. Okay, until the 0 point. So it will reach here. This is the 0 point. it will go by 20 dB per decade. Then after the 0 until 10, it will increase by 20. That means it will reach to positive 20. Now this is 0. If I said 20 dB per decade, it will reach to the 20 on the next at 10 here. So this point here, this point, which is the intersection with the 10 dB, the 10 frequency, is equal to 20 dB. Then at 100, it will reach to 40 dB. So if it goes straight on the same slope until 40 dB, for example, here. Okay, so this is the drawing for the derivative 0. The third one, which is the first order pool. So in the first order pool, we said the pool is 10. You can see here, the pool is the original divided by 10, correct? Over 10, so over 10. So 0.1 is same as, like we said, S over 10. It is the same, okay? That means our omega 1 value that we see before when we drive these drawings is equal to 10. So 10 represent the point of change for our, for the value of the magnitude from 0 point until or by negative 20 dB per decade. Because for the first order, as you can see here, this one is the, the case of the pool, 1 plus j omega over omega 1 at omega 1, which is here, this point. Before omega 1, all equal to 0. After omega 1, it's become negative 20 dB per decade. So it decreased from 0 to negative 20, then from negative 20 to negative 40, negative 40 to negative 60, and so on per each decade. So here from omega 1 to 10 omega 1, that means it represents 1 decade. From 0.1 omega until omega 1, this represents 1 decade. Okay, so the third one here, this comes 0 until 10. Then after 10, it will go by negative 20 dB per decade. These all drawings for, or all body plot for the magnitude for the 3 components. 3 components means the factor, the gain factor, the derivative factor, and also the first order denominator or pool. This is for the magnitude. We said each body plot has 2 graphs, one for magnitude, one for phase. So for the magnitude, now we have these drawings. For the phase, we have the same. We are going to draw the phase for the gain, the phase for the derivative, the phase for the first order pool. So for the phase for the gain is equal to 0. We already see, we already said before that if you have a gain, so your derivative, your angle will be 0 because the gain is real number. So if I said k equal to 2, that means what is the angle of 2 here? It is tan inverse 0 over 2 because the imaginary part here is equal to 0. So 0 over 2 will give you 0. That means the angle for the k will be 0. The angle for the derivative 0 will equal to positive 90. And the angle for the, for the first order pool will be changed from 0 to 45 to 90 based on the previous lecture. Okay, so when we draw this, when we draw this for the phase actually, but just here in this graph, we are going to combine the magnitude values. Okay, so we have these 3 graphs. We want to combine. How we can combine these 3 graphs into one graph? You just need to add, because we are talking about dB. So if you have multiple dBs, so you need to add these dBs. So as you can see here, from 0.1 until 1, what is the value of the magnitude here? As you can see here, we have negative 20 dB scale, slope until 0 here. And the value here is equal to 0. No, for this one is ignored because it is equal to 0. For this one, it is constant number or magnitude, so it is 6 here. Correct? If you have, if I want to know what will be the addition of this point with that point with that point. Now, at this point here, it is the dB is equal, or the magnitude is equal to 6. At this point, the magnitude is equal to 0. So 6 plus 0 is equal to 6 plus negative 14. So it will be negative 20. So it will be negative 14. That means when you add point by point, at this point, that point, that point, that point, that point, all what will be happen? Only the shift of this negative 20 up to negative 14. Why negative 14? Because we have 6 positive, we have 20 negative. So positive 6, negative 20, it will give you negative 14. We add point by point when we want to combine multiple graphs in dB magnitude here. Okay, so what will be the point here at the end of this period or this decay? So here at this decay here, what is the point, the value of the dB? The value of the dB for this line is equal to 0, correct? Because it's at the 0 point. And the value for the ball also is equal to 0, because this is continue to be 0 until this point. You can see this one is 0 until here, no values. But this one at this point only is equal to 0. Okay, here I have 0, but here I have positive 6. So 0, positive 6, it will be positive 6. So this point here, this negative 20 will be shift to negative 14. So it will start from this point. For example, this is 20, this is, this is 10, 12, 14. It will be shift to this point. Start this point and it's go with the same slope of 20 dB per decade. That means the next point not will be 0, it will be the 6 6 dB, which it was here last time. Okay, this is 6 dB, for example. Okay, now it will go with this slope. It will be like this until this one is the 6 dB. So the line here is straight line, but I'm not going in drawing here, see, because the pen is not stable. It will be like this one line, start from negative 14, stop at positive 6 dB. Okay, so this is the accumulative or the summation of the 3 lines or the 3 graphs here. Now if you want to add, if you go after the point here, after this point, which is the point of intersection, after the 6 dB, we still have what happened for this one. It's continue with the same slope. For this one, it's already 6. We already consider it here by adding for this one. But for this one, it's continue 0 until this point. That means it will go this line will go straight until this point, until it reaches to this point, which is the point of 10, intersection between, the point of change or crossover frequency of this point. Why this point? Because at this point we have the frequency, or at this point of frequency, we have another slope. So this slope will go by negative 20 dB. Until this point is go by positive 20 dB. Until reach 10, so we have one positive 20, one negative 20. So the result will be, the slope will be 0. So it will go straight. At the point of 10, because we have this another graph, before this one, this graph no have any effect on our overall graph. But at this point, we have the effect still or appears, because we have another or different slope. This different slope is negative 20 dB per decade. So we have negative 20, positive 20, so the result will be 0. So our new graph or overall graph will be like this one. It's the same like this one. Start from negative 14, go up by 20 dB per decade until reach the 10. Okay, actually this reach the 10 at this point, then it's go for, because we have negative 20, positive 20, so the slope is equal to 0. No more slopes, go horizontally. So this is the overall boundary plot for the three elements or the three components or three factors of our transfer function. This is for magnitude only. Any question about this magnitude calculation? How we draw for the three lines, then how we combine the three lines. If you have any question, please ask, because next will be the phase. If no question, so it's easy for you to solve the assessment, the assignment, also the final exam, also the test. So please ask. If you cannot, you can ask now. No question, see? Still there or not? There is someone want to go to enter the class, yes. Okay, shift lock, okay, shift lock, yes. So no question, go ahead. See, there's someone come. I just back to the class. Okay. The next part will be how to calculate. I already mentioned how we can find the angle. This is for magnitude. The angle for this one is equal to 0. The angle for that one is 90. The angle of that one will be changed from 0 to 45 to 90 based on the previous explanation. So how we can draw? We just come to draw these three angles. I mean, this is the angle for the first one. I mean, is 0, will be 0, like if we have it as a three lines. So the first line will be here on the 0 or the x-axis line. The second one will be positive 90. This is positive 90. The third one will be change from 0 to 45 to 90. But where is the point of change? The point of change is omega over 10, and I mean omega 1 over 10 and 10 omega 1. From where we know this one? From this table. You can see here. I mean, bro, if you just assume that we have omega here change from 0.1 until 1, then from 1 until 10, then from 10 until 100, and so on. So how the value will be changed here? So at 0.1 it will be 90. If you substitute for this one, it will be 90. Then at 1 will be like 84. Then at infinity will be 0. Why at infinity will be 0? Because I mean, if the angle is 90, that means its tan inverse will be 0 value. As you can see from this graph previously, this is the angle for, yes, this one. Okay, here, if you have one pool, so 1 over j omega over b. Okay, this is more clear here. So 1 over 1 plus j omega over b to the power of n. If n is equal to 1 here, we assume that n equal to 1 in our case because we only have first one bracket. Okay, so what is the b here? The b point for the angle case here, we have 2 points. We need to define 2 points, b over 10 and 10b and b. So in our case, we have omega 1 over 10, we have omega 1, and we have 10 omega 1. Okay. So what is omega 1 over 10 here? Because we have omega 1 over 10 because we have the 0, I mean the pool at the point 10. So omega 1 over 10 here represent the point 1. I mean omega 1 over 10 in our case is like omega 1 is equal to 10 over 10. So this is equal to 1. Omega 1 over this, the omega 1, the value itself is 10. This is 10 omega 1 will be 10 times 10 will be 100. So we have 3 points in our example here. We have 1, we have 10, we have 100. So before 1, before the frequency of 1, before this point, the angle is 0. This only we are talking about the case of the first order pool. That means I'm talking about the third element in my transfer function. So before 1, the value is equal to 0. At B1, I mean at B over 10, which is 1, it will go with a drop or with a negative slope of 45. So it will go from B over 10 until B, it will reach to negative 45. Then after that, from B until 10B, it will continue here until reach to negative 90. So after 10B, it will go to infinity. So the form of our graph for the phase angle for this case, it will be like this one. Before, I mean omega 1 over 10 here represent the 1 point or represent the point of 1. So this is 1. This one is 10. And this one is 100. Okay. Y1, 1 represent omega 1 over 10. So omega 1 is equal to 10 in this case. In our case, from this example, omega is equal to 10. So when we said omega 1 equal to omega 1 over 10, it will be 10 over 10 is equal to 1. Then we have the second one, which is omega 1, which is the value of the pool, which is 10. Then the third point is 10 omega 1. This one is 10 omega 1. This one is omega 1. This one is omega 1 over 10. Okay, so these are the 3 points for changing frequency and changing the phase. So this phase here in degree, we already have this one for the gain, for K. We have the 0 here. The whole 0 is for derivative, which is S. The third one will be like this one. Before 1 is equal to 0. From 1 until omega, this omega here gave you negative 45. That means it will be line from 1 until this point to reach to negative 45. Then from omega 1 until 100 here, it will reach to negative 90. It's like this one, same slope. I mean, this line is straight line. Okay. After 100, it will continue to be 90, which is negative 90. It will be in this form, like this one. 0, slope of negative 45, I mean negative 45 here per decade. That means from point 1, from 1 until 10, it will be 45. From 10 until 100, it will be for another 45. So 45 it will be 90. After 90, it will go to 0. From where we got this information? We already draw it here when we calculate for the first order pool. You remember this one, first order 0, this first order pool. Okay, this is 0, negative 45, negative 90. Then we draw it like this one. From 0 to omega 3 here, I mean omega equal to 3. This is the, I mean this is the magnitude, sorry. This one from 0, then it's go to 45. Then from 45, it goes to 90. And from 90 is go to infinity. We said this drawing using the MATLAB, but if I draw it using the, I mean using the using linear or using by hand, it will be like straight, like this one goes down 45, then goes straight. Okay, so this will be our 3 graphs. One is 90, one is 0, one is 0 until here, 45 per decade until this point. So now how we combine these 3 into 1, same like we did with the magnitude, we are going to do with the phase. So we are going to add point by point. So at this point, for example, here from 0 until 10, I mean until 1, this one, okay, from 0 or from point 1 until 1 here, what will be the value? It will be 90 because we have 0, 0, and 90. So it will be 90 until this point. Okay, so it will start like 90 until this point, which is 1. You can see here, this is 1. So it is, if I draw it by hand, it will be like straight line, like this one, 90. Okay, then, but I told you this drawing generated by MATLAB. So when you're going to generate by MATLAB, MATLAB will take many points. So it will be more accurate. But our drawing by using, I mean, for body plot will be approximation only. Okay. So this is from until point 1. Okay. The second changeable here, the change value, I mean, it will be at 10. Why at 10? Because at 10 will equal to negative 45. So where is 10 here? This is 10. This is the 45 here. Where is yes, okay. At the point, at this point, which is 1, the value will be, I have here 90, but this one is go with slope of negative 45. That means this will not continue to be 90. Okay, at this point here, no more 90 because we have another point. The line will go with slope, this slope of negative 45. So this is the slope of negative 45. From this point, that means from the point of 1 to the point of 2, this slope will be by negative 45. Negative 45, that means it will reach to 45 because from 90, if I go by slope of negative 45, I am going to reach to 45 because 90 minus 45, it is 45. So this is the second line here. From where I got this slope, because I have this slope here. So this slope will be start from this point for until I reach to the first, or I complete the first decade. So it is 45. Okay. After this point, which is 10, I have another change point, which is the 90 point. I mean the 100 point. So the 100 point here, this 100 point, it will continue with the same slope because there is no more change. Just continue the same slope until this point. So it will continue with the same slope until this point, which is the 100 here, with the same slope of negative 45 per decade. Negative 45 degree per decade. Okay. Then what happened at this point at 100? At 100, we have another line here. This line, its value is negative 90. And my line there on the top is positive 90. Okay. So if it is positive 90 here and negative 90 here, and both are horizontal line, this is positive 90, this is negative 90. So the result will be 0 here. So 90 plus positive 90 minus negative 90, so the result will be 0. So starting from this point, which is 100, the angle will go to 0. So here reach to at this 100 at the 0 line, then it will continue with the angle of 0 until the end. So this will be the body plot for the phase. 90 until 1. Why 1? Because 1 represent omega 1 over 10. This is point for change of the for the first order. Omega 1 over 10. Why 10? This is omega 1. Why 100? This is 10 omega 1. So if in any case or in any question, if you have first order 0 or first order 4, I mean, if you have s plus 10 or 1 over s plus 10, or you have s plus 3 or 1 over s plus 3, in similar case here, you need to consider what is omega 1. So omega 1 here is the value of the pool or the value of the 0. Then you need to find what is omega 1 over 10 frequency, what is omega 1 frequency, what is 10 omega 1 frequency. These 3 points will be used to draw your phase angle of your body block. So that means you need to identify these 3 points. In the case of first order 0 or first order 2. In the case of the derivative or integral, no need to find these points because you only need to use 1 point of frequency. In the case of the gain, also the same, no need to find these points. Okay, after you combine, you got this graph. As I told you, this is generated by MATLAB. This is for approximation by using hand drawings. So if you go for MATLAB here, this is the magnitude, or this will be the result. If you draw this function, if you just use the code that I gave you before, and also there is another form of the code. There is three type of coding for drawing body block. Okay, so in each case, you just need to write 2 lines of code to generate such graph. So MATLAB will generate for you this for magnitude, the blue one, and this one is for the phase for the angle. So start from 90, go with negative 45 dB until reach to 0 here, then it's continue with 0. At 100, it will continue to 0. Okay. Any question about example number 1? Please, if you have question, just ask, because maybe we don't have time to continue other example. Yes.
For your slide number 50,
Yes.
when the angle is negative 45, why we didn't go down at the graph? We just stay at the positive 45 in the graph.
Again, in the slide
Number 50.
50.
See, here our angle is negative 45, but why we are still drawing the graph at positive 45?
Where? Because the start point, when we say my slope depends on what is the start point. I'm start from this point.
Oh, okay.
We start from the point which is greater than 0. Yes.
Thank you.
Okay. Other questions? For body block questions, either in the test or in the final, you have 2 types. Either I'm going to ask, I give you transfer function, and I ask you to draw the body block, or I give you the body block and I ask you to write the transfer function, like in the assignment case. So please try to practice how to draw the 5 components. I mean, 5 components: the gain, derivative, integral, first order 0, first order pool. And how to draw the magnitude, how to draw the phase, how to combine the different component into one graph. I mean, first draw it individually, like we do this in this example here. Then you need to combine. Combine, that means point by point add. I mean, if you're confusing about this one, just try to go point by point. Try another points here. Try another point here. You will get the same result, because the idea of the slope only will, I mean, the constant value here will shift the line with the slope. Will shift, that means it will take it up or down. Same either for magnitude or in the case of the angle. So the constant value will affect the slope. I mean, will not affect the slope of the line, because the constant value does not have any slope. The slope of this line, of a horizontal line, the slope is 0. No slope. The slope of vertical line is 0. There is no slope. The slope only if you have a line with a different coordinates, either for x or y. That means you have y2 minus y1 over x2 minus x1. This can give you a value of the slope value. Before you go to drawing, you need to rewrite this transfer function in its standard form. Its standard form means you need to have this value equal to 1, this value equal to 1. We don't want to see 2 and 10. So what we need to do here, we are going to have like j omega over 2 plus 1. This will be j omega over 10 plus 1. So this will be the new 4. Then you have here the 200 j omega. But if you divide this one over 10, divide this one over 2, you should to divide this one also over the same number. So it will be like 10 times 2, it will be 20. So it looks like you are dividing by 20. So if you divide this one by 20, so 0, 0, 2, 2, so it gives you 10. So this is the new form. 10 j omega over 1 plus j omega over 2, 1 plus j omega over 10. So now you have the 4 element, no change, nothing changed. You divide yes, but nothing changed, just the value. So the gain here, instead of 10, it's become instead of 200, it's become 10. Why 10? Because I convert the transfer function into its standard form. So it's become j omega, 10 j omega over 1 plus j omega over 2, 1 plus j omega over 10. Okay, now the magnitude for the previous one, I mean for the 10 value here, it is 20 log 10. The magnitude for j omega is the magnitude value of the j omega, which is 20 dB per decade. The magnitude for 1 plus j omega over 2, this is first order. And we said for the first order here, we need to consider the value of omega 1 in the magnitude and the value of omega 1 over 10, omega 1, 10 omega 1 in the phase. So for these two elements, you need to consider these values. So what is omega 1 for the first one? It is equal to 2. What is omega 1 for the second one? It is equal to 10. So in this case, when you draw, you need to consider these elements. Okay, now you go one by one. So for the magnitude here, the magnitude in dB will be 20 log 10, 10. Okay, so plus, this is for the first, which is for the gain value, plus 20 log j omega. This will give you the 20 dB per decade. This one minus 20 log 1 plus j omega. This will give you the second one, which is the negative 20 dB per decade, but starting from the point of 2. And this will give you negative 20 dB per decade, but starting from the point 10. For the angles, for the gain here, the angle is equal to 0. For the derivative, the angle is equal to 90. For this first order, the angle is changed from 0 to 45 to 90. Then for this one also the same, from 0 to 45 to 90. But both of them will be changed based on this value of frequencies, omega 1 over 10, omega 1 and 10 omega 1. How we can draw these things? You can see to this graph. So as you can see here, the dashed lines represent the individual representation for each element, and the red line, the red continuous line here, represent the overall drawing for the body plot for this transfer function. So if you come to the first one, which is 20 log 10, this represents for the gain k. K equal to 10. So 20 log 10, it gives you 20 dB. The second element is for the 20 log j omega, it gives you 20 dB per decade. As usual, starting from negative 20 here and reach to 0 at 1, then reach to 20 at 10. At 10 reach to 20, then it will reach to 40 at 100. If you go for 100, it will be 40. So the slope here is continue with 20 dB per decade. That means the slope will, or the value here will be increased by 20 dB per each 10 values of frequencies on the x-axis. So each 10 value we got extra 20 dB, 20 dB, 20 dB. Then you come to the second or the first order element, and the first order element, we said we have two first order element, one with omega 1 equal to 2, one with omega 1 equal to 10. So what will be the difference between both? Both they have the same slope, which is negative 20 dB per decade. The problem here, I mean the difference here will be the value of the frequency which they will change. So to perform, I mean, in the first case, omega 1 is equal to 2. In the second, omega 1 equal to 10. So you can see here, this is the drawing for the first one, which is at the point of 2 here. Before 2, the value here equal to 0. For this element or this factor here, before 2, the value equal to 0. After 2, it's go by negative 20 dB per decade. That means negative 20 dB per decade at 2 is equal to 0. At 20 will equal to negative 20 dB. Okay, that means at the 20 here, if you go use line here and go there, it will be negative 20 dB per decade. I mean, I just want like this one, it's 20 dB per decade. If you go for after 20 will be after 10, that means it will be 200, it will be negative 40 dB. After 2000, it will be 60, negative 60 dB and so on. So this is for the first order element. For the second order element, which is, or the first, I mean, for the first order second element here, which is omega over omega 1 equal to 10. Before 10 is equal to 0. After 10, it's go with the same slope, which is negative 20 dB per decade. So you can see these two lines are in parallel. So because they have the same slope, slope is negative 20 dB per decade. When I said negative 20 dB per decade, I means at the 10 will equal to 0. At 100 will equal to negative 20. So if you go there, this is 100, it's the same line here. At 1000, it will be negative 40. At 10,000, it will be negative 60 and so on. So this is how we can draw the 3 or the 4 individual components of our transfer function body plot, the dash line. Then we come to combine these 4 lines into one line only, which is the red line. How we combine? We go point by point. So I have at the 0 point here or at point 1 here, at start point, this equal to negative 20. This is negative 20. This one, the second one, I mean, this one is equal to 0. This one equal to 0. For that, no, there is no value. I have only this value here, which is on the same point. So negative 20 and positive 20, that means my shift or my line will be shifted by 20 up. 20 up means it will reach to 0. Because positive 20, negative 20 give you 0. So we will start from 0 instead of starting from negative 20 or from positive 20. So when we start from 0 here, our line will be drawn at the same slope, which is 20 dB per decade. So at the point 1 here, it will reach to 20 dB. So this is the slope of 20 dB per decade, 20 dB per decade. After this point here, from 1, after 1 until 2, it's okay, still the same slope. But when I came to point this point here, I have a new line, which is here. It's come to be considered, need to be considered or to be taken off. Okay, so when this will go for negative 20 dB, and that one is go by positive 20 dB, which is here this incremental 20, this decremental 20. So the result will be 0. So the line will go horizontally here with a slope of 0 until reach to the 10. Why 10? Because at 10 we have another changeable frequency value. So this value here at the 10 here, we have another negative 20. So now we have negative 20 from this one, negative 20 dB per decade from that one. We have negative 40, positive 20. That means the result will be negative 20 only. Okay, because we have negative 20 from this line, negative 20 slope from that line, positive 20 from that line. So the result will be negative 20. So this will go for negative 20 dB per decade. So from 10 here until reach to, I mean, from 20, from the 10 point here, start to go with the negative 20 dB per decade. So start from 10 until reach to the 100. So it will reach to the 0 point. Then continue with the same slope. So this is how we combine the 4 individual body plot into a single body plot. So usually the gain only will shift the line, and the the slopes will be considered. If there is one slope or two slope or three slope, you need to be considered their slopes. So this is, for example, this we said this is negative 20, this negative 20, this positive 20. So the result become negative 20. So this go by negative 20 dB per decade. Okay, so if you draw it by using MATLAB, it will looks like this one. It's more smooth. This is for the case of the magnitude. In the case of the angles, also we have the same. We have the same. We have the 4 drawings here in the dash lines. First is the 0 for the gain, so it's not considered. It is along the 0 or the horizontal axis of omega. The second one is the derivative, which is positive 90. So this is the line for the derivative, which is for j omega. The angle for j omega is equal to positive 90. The angle for 1 plus j omega over 2 is start from omega over 10, which is 0.2, until 2, then 20. So this is the 3 point of change for the first order element j omega over 2. 0.2, which is omega 1 over 10, and 2, which is omega 1, and 20 is 10 omega 1. So as you can see here, this line start from 0.2, 0, before 0.2 is 0, then it's go by negative 45 until reach to the 20 point here. In the middle here, we have the point of 2, this equal to 45. The second one, which is the first order also, but second one, which is j omega over 10. The omega 1 will be when we have omega 1 equal to 10. So 10 over 10 will give you 1. So this is omega 1 over 10, which is 10 over 10 is equal to 1. And this is the omega 1, which is the point of omega 1. This is for the second element, omega 1 for the second element or second factor. And here we have 10 omega 1, which is 100. So the 3 changeable point is here. Is the point, I mean the omega 1, which is here, and the 10 omega 1, which is here, and the omega 1 over 10, which is here. So as you can see, from this line start, before it all 0, after it, it's go for negative 45 dB per decade, until reach to the 100 here. So after 100, it's go with 90. Because it is the same 90, or I mean negative 90. Then we combine or we add all these points for the 3 graphs. So point by point. So how we add? The 0 plus 90, it is 90. So it's give you 90 until this point. This point we still have slope. We start to have slope. So this slope is negative 45. It will go by negative 45. Negative 45 per decade, that means from this point, which is 0.2 until 2, it will go with the slope of 45 degree. I mean negative 45 degree. Then at this point here, we have another slope, which is negative 45. So it will be like with the slope of negative 90 degree. Go down until the new, and then the changeable point, which is 20, now start to adjust by because we have positive 90, we have negative 90, so positive 90 will go with the negative 90, so it will continue with negative 44 again until this point. Then we have positive 90 and negative 90, it go with the slope of 0 until that. So this is how we can combine the different angles and the different magnitude to draw the body plot for transfer function. This generated body plot by using by using MATLAB. There is one slide here that I want to show you. You can snapshot or you can screenshot this one. This the different type of codes that you can use with MATLAB to conform or to double conform your body plot. Okay, you may draw the body plot by using Simulog paper. Then you can generate it by using MATLAB, by using any of these code. The one that I already verified with you last time, which is now using the numerator, denominator, and then you draw the numerator and the denominator. Or you can use this for you write transfer function, which is TF. Here inside this one you put the gain value, which is K, and here you put the poles or zeros. Okay, so whatever is the number of poles or the number of zero here, you need to slot to write there, and you can draw. Or the most common one, this way, you use ZBK. So it's like a representation for the zero and the pole and the gain. So in the first one, it is the zero. In the second one, is the pole, and in the third one, it is the gain. Then you make like body for G, then it will give you the body plot for this transfer function. So Z, P, K, 0. So how many is it? I mean the place of 0, where is the 0? At 0 point. Where is the place of the pole? It is at -2, for example, and -10, and or based on your equation, what is the value of the gain, which is K here? It is 200. So this is how to write the transfer function, and then how to draw this transfer